Hello, I'm Chandra. What follows in this video are explanations to some selected QA questions from our course. The link to the courses is in the description below. A question will be put up and I'll immediately start solving it. What you need to do is pause the video as soon as a question is up, give it a good try on your own, and only then continue watching the explanation. Without trying the question, if you just sit and watch the video, you would be wasting your time. I strongly urge you to give it a try and then compare your approach of solving with the way I have explained the question. That's the best way to make use of this video. A tough question. You can learn good problem solving skills from this question, so pay attention. We are given a quadratic. A and B is not known. Constant is 6, so the product of roots is 6. G of x very similar to that. So now we have 4 variables A, B, C, D. One root, that is P, is common to both f of x 0, g of x 0. So now here we get to know, okay, this is from the topic of a common root. And common root topics have two different approaches. The first approach is, you write the coefficients and then you do the short product and the long product. Now, if you don't know this is not the place to learn these ideas. Okay, there is a formula for when other this, but this is a very cumbersome one. Right, so I'm not very enthused about using this, especially in a new type question. If it's a standard question that I've done earlier, it may be. The other is you just plug the common root, you plug x is equal to p, solve two simultaneous equation. This is also not very easy, simultaneous equation. And what is important here is solve for p, solve simultaneous equation for p and plug it back and plug back. So this, now all this is theory which you should know from your theory, right? This is just a revision quick. So these are in my thoughts when I read that A, B, C, D are in an arithmetic progression. Makes it more difficult. Okay, so now there's a link to AP also. And the question is find the common difference, all are positive. So for an AP, instead of 4 variables, when we read this, there were 4 variables, one of a good problem solving skills. If they are in an AP, you can make do with just 2 variables, the A and D of the AP, but that A and this A will conflict or confuse. So X is a variable, P is used here, so I'll just use Q and R. 4 numbers in an AP can be assumed as Q minus 3R, Q minus R, Q plus R, and Q plus 3R. Okay, and here remember the common difference, many people will make a mistake, is 2R and not R. Okay, so this is a very standard technique of using 3 numbers, 4 numbers, 5 numbers in an AP. So I am not doing anything new, and this should have strike a good well prepared student, yes. And what helps you is instead of 4 variable, now there are only 2, Q and R. So I'll prefer the second method because this looks very cumbersome when I try it with these Q and R. So instead of A, I'm going to put in the common root, and instead of A, I'm going to write this. So pay attention, be a little careful. Q minus 3R times. Instead of X, I'm putting the common root. So that's P square minus B is Q minus R times P plus 6. And because P is a root, the value of this becomes equal to 0. This part is also significant, right? Let's write it for C. C is Q plus R. Oh, is it Q plus 3R or Q plus R? Q plus R. So I would have loved it if it was Q plus 3R, because then I could have. So this is what you think ahead. Yeah. And what does D become? D is Q plus 3R. Okay. And into P plus 6. Now, in a standard approach like this, when you solve simultaneously, we make the coefficient of P square equal in a typical situation. But here making them equal is so very difficult. You multiplying the first with q plus r, multiplying the second with q minus 3r, it's pretty difficult. Though when you multiply it, it becomes q square minus r square. This becomes q square minus 9r square. Okay, but here there is a problem. And if you think a little ahead, you see the 6 and 6 is same. So why don't I just subtract this and eliminate the constant? Instead of eliminating p square, eliminate the constant. When you subtract that, do you see some incentive? The q and q will get cancelled and I'll only be left with r. Here also the q and q will be cancelled, I'll be left with an r. These are the problem solving skills that I'm talking about precisely, right? Also look ahead, you'll get a term in p square, you'll get a term in p. The constant has gone out. So p square p, the p and p will cancel out and you'll get the value of p. That is what I need, and then plug that value of p back into this equation, right? So I think so it's very obvious that one should be subtracting this. Now subtract it your own way. This minus this, the q cancels out. This is going to be a minus 4r into p square. Please do your own way, students. Don't follow this. Yeah, these are just small things. So this minus of this, when I do minus of this, this is going to become plus. Minus q plus q cancels out. Plus r plus this is going to become a plus 4r times p. Alright, this is a plus r and this is going to become a plus 3r, 4r times p. Okay, and this minus this cancels out, so this is equal to 0. Oh, great. So the this minus 4 will become a plus 4, the 4 cancels, the r cancels, the p will cancel, and you will directly get p is equal to 1. Wow, it just, so this is what, when you try something, you will find something easy. By just sitting and worrying is not going to help us, right? I did not know it would turn out to be so very easy. So just plug p is equal to 1 here. Yeah, plug it back into this original equation. Okay, so I'll plug p is equal to 1 back into this. So I'll have q minus 3r minus of p is 1. So, okay, so this is q minus of r plus 6 is equal to 0. So if I see this, I see the q and q cancels out and I'm only left r, and that is what I want. Okay, so q and q will get cancelled out. How about the r? This will become plus r. So this is minus 2r goes to the other side, 2r. Oh, so I directly get r is equal to 3. Solve it on your own. The answer is 2r and not r. So 6 is my answer. 2 inlet pipes filling up a swimming pool. We know the time taken by each of the pipes individually. So that's some comfort area standard data. Now both pipes are open together for a certain time, but due to clogging, only 5/6 of the full quantity flows through A and 5/8 through B. So what I can do is, since the inflow is only 5/6, the time taken will no longer be 10. The time taken will be more. So 10 into 6 by 5. One thought in my mind is, if it continues at 5/6 of this, it is going to take 12 hours. Okay, to fill. And this takes 5/8. So the other one will take 24 hours. So how did I do that very fast? The flow is reduced. Right, so the time will increase. So increase in 8 by 5. So multiplied 8 by 5. 5 3s are 3 8s are 24 hours. So with this reduced rates, those timings change. Okay, so I've handled this also pretty well. Now after some time of opening, the clogs are detected and they are removed. Okay. The remaining part of the pool is filled in 75 minutes after the repair. Now, so for some time, the clogged one were working, and for other time, now the clogs are removed. Or if the clogs are removed, we are back to that time. Okay, it's a little tough, but not so tough. So I'll continue on this line of thought since I'm comfortable with it. Later, I'll explain an alternate way. So continuing with this line of thought, I will see that at full rate, the full pool will take how much time? 10 into 15 by 10 plus 15, and this should be very fast in your mind. 25, 150, that is 6 hours. 6 hours it takes, that is going to be nothing but 360 minutes. So 360 minutes, but actually only 75 minutes out of this 360 minutes is the this situation working, right? In 75 minutes the pipes are working at their full part. So this what will cancel? 15 will cancel it. Yes, I guess 15 will cancel it. 15 5s are 75, 15 2s are 30, 24. This much part of the tank is filled when the clogs are removed. Okay, this much part of the tank is filled, right? So with the A and B working at their full capacity. So what this also means is the rest of the time, what is it? 19 by 24th part is filled when they were clogged. When they were clogged. You don't need to write all this. I have to do this to explain, right? Okay, and when they were clogged, this is what I have. And when the pipes were clogged, could I say they would fill the full pool in how much time? In 12 into 24 over 12 plus 24, that is 36. 12 plus 24, 8 hours. 8 hours is nothing but 480 minutes. Okay, so the full pool could be filled in 480 minutes. So 19 by 24th part of the pool will get filled in how many minutes? That many minutes the clogs were working. So it's less time, so that will also be less. So 19 by 24 into 480, that is 380 minutes is my answer. And I think I've done it pretty well, students, with the flow of thought, how it was going, without getting worried. So it's a good job, right? Now for those who do not like this too much of thought, then you could have just tried it in the typical way. Assume the tank. So let the pool be equal to the LCM of 10 and 15. That's nothing but 30 liters. So if you take 30 liters, the rate that translates to A ka rate is going to be +3 and B's rate is going to be +2, right? 15 hours, 30 liters. But then you also need to do this. This should be a multiple of 6. I would have liked it to be a multiple of 6, because if the clogging is 5/6, the rate will become 5/6. This is not a multiple. Similarly, I would want this to be a multiple of 8. So you want this to be a multiple of 6. You want this to be a multiple of 8. So multiplied by 4. If I multiply it by 4, this will become a multiple of 6. This will become a multiple. So 4 times. So redo it immediately. So 4 times. So this will become +12 liters. This will become +8. So now go ahead and look. For some time, we do not know what time, the rate was not 12, but was only 5/6 of 12. Now you don't need to write all this. Yeah, this is this plus 5/8 of 8. This was the rate for some time, plus after that it was full rate. The full rate is full 12 plus 8, that's 20, right? 20 into 75 minutes. And can I say this rate, this is the work done is 120 liters. This is the rate of filling, 12 plus 8. Okay, this is the time, the rate into time is the work done. This is your work done. So it's not 1. Don't make that error. You're working on the LCM way. The work is a defined quantity, right? And this also I think should have been orally done, students. 10 and 5, 15x, 15x plus 75 into 2, 150. So now what's wrong over here? Is it the minutes and the hours that is wrong? Yeah, I guess the minutes and the hours that is wrong. So this time that I should take is 75 is 1 hour 15 minutes. No, 1 hour 1/4. So that is 5 by 4. So 5 by 4, right? 4 ones are 4, 5 by 4, 25. So this is 25 is 120. So X will be 95 by 15. These many hours. So to change it to minutes, I'll multiply it. So I should get the same answer. Let's say 360 and this 380. So again, very nice. We saw that error also that happened and we took care of it also.